Hi, everyone. My name is Arthur Hicken, and I'm the evangelist at Parasoft Corporation. And we're going to talk today about how AI is a game changer for software testing. Now, before we get into that, I just want to quickly cover Parasoft. We've been around for about 35 years, and we are a leader in many, many areas in software test automation, including unit testing, static code analysis, API test automation, service virtualization, etc. We've won a bunch of awards. So if you want to check any of these things out, just give us a holler and let us know. What we do is help our clients produce high quality, safe, secure applications that have to work all the time. And these days, we do it using solutions that are augmented with artificial intelligence and machine learning. Now, artificial intelligence capabilities are changing today. We've gone from, simple chess programs to chatbots to, the last 6 months or so, everyone's had the opportunity to play with things like ChatGPT, OpenPilot, etc., Copilot. And the real question is, as we see these large advances, what's going to happen for us? How are we going to be able to blend the human capabilities with the AI capabilities to get the biggest outcomes? And one of the things I really like to focus on is what AI-powered testing can do for us today, right now, not a year from now or 5 years from now. And the things that AI can do right now are test creation, test execution, test expansion, test efficiency, self-healing, noise, relevance, risk, and all kinds of interesting things like that. So today we've teed up for you a discussion with our Chief Product Officer here at Parasoft, Igor Kirilenko, to talk to you about AI. And he's going to talk to you about some really cool things that we've been doing and how we use AI. We use all of these things ourselves. We use all of our own tools. We're our own customer, as well as many of you may be, and many of you may soon be. But we're going to show you how AI/ML is going on today in various areas. So I hope you enjoy it. And with that, take it away, Igor.
I hope you can see it now.
Yeah, we got you.
Okay, today's very exciting topic. We're going to talk about AI and how it can be applied to software testing practices to bring the value to the customers. And when I'm talking about AI, usually I mean a kind of broad definition of AI. I'm thinking about its kind of ability for computer systems to exhibit the human's behavior in forms of reasoning, kind of thinking, and learning. And usually learning is based on, obviously, observation pattern, collection of the data. And the most important here is ability to change the behavior of the system based on what the system learned. Usually it's associated with machine learning, but AI and machine learning terms used very often together. So when we talk about that, I want to first spend several words talking about the Parasoft Continuous Quality Platform. That's our offering, which actually provide a lot of different tools and testing practices to help our customers improve the quality of their software, and assess the quality of the software. They can use static analysis for that purposes, running them against the code even before it's been compiled. They can use unit testing, obviously. In front of functional, non-functional testing, we're offering SO test solutions which focus on API, and as well as we support mobile testing, UI-based testing, and so on. Service virtualization is a big part of that because it allows you to decouple your software from external services to improve your testing capabilities. You can read all those about our products and offerings on our website. Today, I want to emphasize that this is pretty open systems because our tools integrate with open source frameworks, and you can run them as part of CI/CD pipelines through Jenkins, or for example, cloud-based solutions such as GitLab, GitHub, Azure DevOps. The system, obviously, intelligence, and that would be the focus of today's discussions about AI and how we can behave in the smart way. And it's actionable because at the end of the day, the system helps the developers and testers to improve the quality of their software through recommendations, through fixing some problems, suggestions how that system, how the quality can be improved. Probably the best way to look at all those different testing practices, because we're talking about automation of testing, is through CI/CD pipelines. That's where traditionally you want to see all your testing happening, right, as part of your pipelines. And traditionally, we'll start on the very left, or if you're talking about the testing pyramid at the very bottom, because this is the foundations of the quality, it's execution of static code analysis. It obviously helps to detect any security, a lot of different reliability issues, detect, for example, race conditions, error handling. It helps software development organizations enforce the security standards, such as OSP, CWE, CERT. And another interesting side effect, it helps to enforce development teams to follow the best development practices. And in general, it's great techniques for preventions and error detections. It becomes standard for safety critical industry to adopt static analysis for compliance with different standards. But you can see that it becomes very common for other verticals, financial sectors, for example, e-commerce, because the security becomes a big concern. The static analysis helps to detect those problems in proactive manner. The challenge, though, when the software development organizations try to use static analysis, it's not about integrations and how to start using it. It's really easy to integrate in your CI/CD. But when they turn on those rules, and very often it happens in the middle of your development cycle, so maybe even closer to release time, their developers will be overwhelmed with, for example, detection of 1,000 different violations which start popping up. And now they might be confused or overwhelmed with the fact, like, how they're going to fix them, which of those violations they need to start working on first. And that's where we have multiple different techniques from AI perspective, helping them to actually address that particular problems, start working on those violations in performant manner. The first investment we did from the perspective of AI was applying different classifications techniques to violations which have been reported and detected against the source code. And we using classifications here to observe the violations which were fixed previously by the developers inside the system. And based on that, we can predict which violations in the future come into the system has to be fixed or suppressed. Intuitively, I can give you an example. If you have a developer in your organizations who doesn't follow the best development practices, and obviously he introduced a lot of, for example, bad code, which will be triggered produce multiple different violations, at the end of the day, they will be fixed. The system will learn and associate with that developer that any future violations comes into the system which actually produced by that particular person most probably need to be fixed as well. So it will highlight them with a higher probability that they need to be addressed. At the same time, if you have some rule which actually regularly executed and produce violations which development team doesn't care much about and mostly suppress those violations, eventually the system will learn that violations coming from that particular rules might be low priority and preferably might be suppressed in the future. So this way, this classifications technique allows us to filter out what we call noise and highlight those violations which come into the system which most probably need to be addressed by development teams. The next AI techniques we're using is called matrix factorizations. Basically, what we're doing, we again observe what violations each developer is fixing, and then we create profiles associated with each developer, understanding on the type of violations they're working on. So basically, we call that we learn about their skills. And now, when the new violations come into the system, we would automatically suggest which of the developers, based on his experience in the past, is most suitable to address those violations. Think about this approach as you Netflix. When you watch your movies, you like some of those movies or some of those not, and the system kind of learn from that pattern and suggest you new movies to watch in the future. It's a very similar approaches here. The idea behind this is that the flow of violations come into your system can be distributed across your development organizations based on the skills and what they did in the past. Another enhancement we actually made is helping the users to group violations according to root cause analysis. We analyze, for example, entire space of violations which exist in your products, and then we detect those common problems which might be associated, for example, with one single line of the code, but that particular problem inside that code may be exposed in like tens or even 100 violations. To give you an example, for example, you have problems with initializations of one of your objects in the class. And then everywhere around your source code where you try to reference that particular object, you'll probably start getting like null pointer exceptions or some other problems. So the exposure of that problem can be visible through multiple different violations, but the root cause is just one single line of the code. So what we're doing here, we detect those hotspots, and we assign them to individual developers. Now, instead of the benefits here, that instead of people jumping and trying to address hundreds of those violations at once, they're actually looking in this one particular single root performed based on root analysis, find this particular line of the code, address them, and that will fix entire class of violations associated with this hotspot. So obviously, it gives the highest return on investment for development organization. And other techniques, which we consider to be very advanced, and this kind of still work in progress, it's based on actual leveraging of neural networks. What we're trying to do here is to build a cluster of violations which, based on similarity of the code, which kind of surrounding those violations. And the idea and principle here is that when developers are working on violations, always trying to fix the violation in the context of the code, right? Whether in the context of methods or entire class. So the developers kind of learn about the semantic of the code around that. And when the problem is fixed, we want that developers to start addressing another violations, but in the same kind of mental context of the code which he already just learned. So we're trying to find similar code in the entire project space, which doesn't have to be exactly the same code. Obviously, we're not looking for exact duplications, but semantically close enough. So when we'll suggest next violation to be fixed, it will be in the context of the same kind of understanding of paradigm and semantic of the code itself. It's very difficult and tricky problem to resolve. We have to perform kind of vectorizations of all the methods inside the project, and each method will be associated with what we call the signature, which are representations of semantic meaning of the code. And now what we can do, we can compare all the vectors between each other and find those which match the closest, and that's how we will find the next recommendations of the violations based on the similarity of those digital vectors. Today we're using a neural network called Code2Vec. It's open source, but we're looking into other transformers which kind of can give you better, for example, signatures, better vectors, or give you, like, improve the quality maybe with less size of the network itself, because we sensitive to how much we need to deploy on the user's machines, and based on performance, we're looking for something that will do it very fast. If I combine all those different techniques together, in specifically addressing this problem of handling big number of violations coming into the systems, we can consider this workflow. Like, let's assume 5,000 violations come to the system, right? The first things we will do, we will analyze them from classification perspective and clustering, trying to filter out those which we will consider to be lower priority. Then we will cluster them to detect hotspots and perform the matrix factorizations to assign those violations which we treat at a higher severity to the developers based on their skills. Now, every time when developers are going and fix the violations which we recommend to address, we will perform this code analysis and find a similar violation. Well, violation could be different, but find a similar code with violations which user can focus on. All those techniques working together helps us to optimize developers' performance when they actually focused on fixing those issues which considered to be the highest in terms of priorities. So that's kind of what we're doing on the level of code analysis. Now, the next testing techniques, which widely adopted, is obviously unit testing, and it's well-recognized value in terms of it helps to identify a regression issue, protect your code from unexpected changes, not to break the behavior, reduce the risk of those changes, and very often we know that unit test helps to write a better code design, right? If you follow the good patterns and may focus on making your code testable, usually it results in the simplifications of your structure of your code, your architecture, and it generally produces a better code design. And very often unit tests associated with specific code coverage, which you need to reach on the higher level, and associations of those quality characteristic back to your requirements. Though unit testing is common practice, but it's not the easy one. Because creation of meaningful unit tests means that the tests need to be probably isolated. You probably want to use some mocks. You need to use some assertions to assess the quality and result of execution of your test. You need to reach certain level of code coverage. And another problem associated with unit testing is maintaining those tests over time when your code changes continuously. So overall, it requires a lot of efforts on the developer side, it's time consuming, and it might be overwhelming. We know that it might be up to 40% overhead for developers to continuously invest in unit testing. So here we apply another AI techniques, specifically target unit testing. It doesn't matter whether our developers are focused on creation of brand new unit tests with focus on targeting specific line of the code in terms of coverage, or maybe they want to mutate existing tests and add more testing to uncover additional blocks, or maybe even create a bunch of new tests associated with legacy code, generate them at once. What we'll do first, we'll build such a sophisticated model that understand all the sources of your projects, and then we merge it together with our flowed analysis engines, which has capabilities to discover all possible paths of executions of your code, and it associates constraints with every path. Constraints, I'm thinking about if conditions, switch conditions, and so on, which actually controls the flow of executions. Now, with every other path, which we call recipes, we associate the number which represent the complexity of the code, what the coverage number can achieve if we go through that path, maybe how much mocking you need to implement as you do. And based on the scoring systems, our intelligent engines actually pick up those recipes which we think will give the biggest benefits to the customers. And we resolve all those constraints associated with those selected paths. We will discover what variables, how they need to be initialized as the input parameters to your methods, or for example, how your mocks need to be initialized to specifically route execution of the test through that choosing the path. We'll generate the unit test with all the initialization values, and then in background, we'll automatically run that. The purpose of that would be to measure the coverage and do some test optimizations, as well as auto-generate assertions. So end result will be automated way to create the unit test. And we strongly believe that autonomous unit test generations is actually the way to go. But we know that state-of-the-art AI today might not give you the 100% code coverage, and it really depends on complexity of your code. So if you're only relying on autonomous test generations, you might hit that threshold above which you cannot go, unless you as a developer start investing and writing those unit tests yourself, adding on top of what was already generated. So that's why we believe that their end game results here would be combinations of autonomous unit test generations with some kind of assisted test creation technology, which can guide the user to help them to clone those tests, for example, create new mutations, generate mocks in automated fashion, help to generate those assertions. At the end of the day, combined approach will allow the developers to achieve that higher level of code coverage. It might not be 100%, but it could be 80, 90, depends on the policy of development organization. We not only focus on unit test generations, but as I mentioned before, we measure the coverage associated with them, and then we apply some optimization techniques, because some of the unit tests might not bring much of the value. It's maybe exactly or duplications of execution paths which were executed before. So we try to optimize by removing those redundant tests. That's one of the way to increase the maintainability of your testing infrastructure, reduce the cost associated with maintenance of your test by removing those which kind of redundant. The next level of testing which we promote, it's mostly shifting now to kind of end-to-end testing. It's more like functional testing. We're talking about API testing. API testing techniques, it's very good in terms of how fast it can be executed. You'll get quick response from the systems. It's very reliable. And here we offering AI machine learning techniques, which helps to create those tests in automated fashion based on the observations of usage pattern. I'll talk about this a little bit in more details. And of course, the value of API tests on themselves, that you can reuse them for load performance testing or even for penetration testing. I'm not going to cover that part, but if you'll stay with us, the sessions, I think 30 sessions today, will be talking about this particular area of functional testing, where we'll talk about APIs, performance penetrations, and we'll talk about service virtualizations, which works really well together because it helps to decouple your software, your program under the test from external services through simulation of behavior of those services. So right now, I just want to more focus on how we help the developers to auto-generate those API tests. And for that purpose, we're using smart API test generation technology. The way how it works, well, first of all, where the problem is, it's traditionally when you are testing your application through UI, you kind of don't think about which APIs used by the front end underneath. And the business logic of those usage of APIs built inside the front end, and you basically execute the actions inside UI, and all the magics happen behind the scene. But when you are focused on API test creations, in terms of testing, you might look at the documentation and understand the description of each API method, but you might be puzzled in terms of how to combine them together in some functional flow, right? And that information might not be straightforward and obvious, especially if you're talking about very complicated systems with hundreds of APIs. So what we're doing here, we help users by intercepting the traffic which comes from UI. It doesn't have to be UI, it can be from another external system. As long as we have access to the traffic, we build the models which understand all the inputs and outputs, all the parameters which actually sent to their system under the test, and the results returned back. We can do parameterizations of those parameters, understanding their meaning and how they've been used. And then based on these informations, we auto-generate those API tests, totally decoupling them from UI. So at this point, you have your test, which can be independently executed. And from applications point of view, it's actually exhibit the same behavior as it was driven through UI. And after that, you can change the behavior as much as you want, because you have the base of API tests created for you. So generally, we have plugin for your Chrome browser, which basically detect the traffic which comes from the browser based on UI test executions or manual test executions. But it doesn't have to be just UI. We build the system, the models which kind of represent, capture the behavior of APIs, and we automatically generate those tests for you inside the SOA test. Obviously, the more you use the system, the more we train our models, we capture more advanced scenarios, and then we will be able to generate more advanced tests as a result of that. And we make some enhancements specifically to tune up for testing package solutions such as Salesforce and Guidewire. So you can take advantage of that. The overall concept behind this is record and replay, where AI actually focused on building those tests for you, and then you can replay them as many times as you want. Even though we promote API tests as one of the fundamental functional testing techniques, you cannot go without actually testing your UI, right? It's de-emphasized because you know that UI test is very flaky sometimes. They're not stable. It takes much longer to run them, but because there's a lot of business logic on front end, you kind of have to test it as well. And for that purposes, we have Selenium. It's our web UI-based solutions, which we built on top of Selenium framework. It helps to automatically create Selenium tests for you, but another level of another value which it provides, it's actually self-heal your test during executions at runtime. And it can be self-healing based on broken locators, or for example, based on weight conditions. On top of that, it's not only for mitigation of the problems during executions, but then at the end, it will generate very advanced, sophisticated report telling you exactly what was wrong during executions, how the problem was fixed, and it will give you recommendations as a developer how you can change and fix your test to address those problems inside your code. On the high level, the way how it works, it starts with the same plugin inside your browser, which actually record all the user actions executed during manual test. Based on that information, we can automatically generate Selenium tests following this best practices using like page objects model. And when you run those Selenium tests, and they don't have to be only our tests generated by Selenium, you can use your own Selenium tests, assuming you already have, for example, 100,000 of them. Let's assume you run them as part of your CI/CD pipelines from Jenkins, for example. We observe the execution of those tests, and as the test's running, we capture all this like information about your DOM models. We understand the relationship between all this UI's element on the screen. If test fails, our engine goes back to historically discover that previously executed tests which were successful, make a comparison to figure out what was changed in UI, where those elements moved, or maybe IDs change, and it will automatically recover all the tests, reapplying this based on this information learned from the previous successful execution, and try to recover and rerun the test, continue running this test. It can be actually weight condition as well. The benefits here that when the user comes back to the office, if, for example, he runs long sessions of UI tests executed overnight, in the morning, it's not that he will discover the test was broken at 5-10 minutes after it started, and then he gets nothing, and then wasted like entire 12 hours. It will see results of all the tests being executed, will generate reports which will highlight which tests were kind of self-healed, and then we'll send those recommendations back to the IDE environment where a user developer can fix those tests. The interesting point here that you can reuse the same recorded actions and traffic from captured by the recorder from the browser to automatically generate API tests as well, as I mentioned before. So once you record one manual sessions through the browser, you can produce your UI-based testing, and you can automatically create your API tests and run them together. And as I mentioned before, they are tuned up for Salesforce and Guidewire testing as well. So again, the same concept applicable here, record and replay with, in this particular case, with self-healing capabilities. Overall, if you look at this testing pyramid, we kind of went through the bottom up and talk about all different automated testing techniques and how we can enhance them, applying those different AI and machine learning methodologies. On the very top, though, we what's left here is like manual test executions, and we know that manual tests takes a lot of time to run, and even though we're promoting automations everywhere, but sometimes you have to run manual tests as well. Here we're trying to help our testers and developers to optimize their time of executions using what we called smart test executions. It's based on test impact analysis. And actually, these techniques not only applicable to manual tests, but it's actually applicable to all testing techniques which I mentioned before, executed inside, for example, your CI/CD at runtime. The way how it works is that with every test which we have, we measure the code coverage which is associated with the test execution. So we have this correlation between test and each single line of the code which actually touch. When the developers change in the sources, and we can perform analysis based on the source level, or we can analyze your binaries for Java code, for example, we can detect exactly which lines of the code were changed and trace it back to those tests which associated with those lines of code. Now the system is smart enough to recommend, based on what was changed, subset of tests which you need to re-execute to validate those changes, and that would be sufficient enough. So instead of running like thousands of tests, which can be very time-consuming, you can just spend friction of the time, rerun only a small subset of those tests, and still get the confidence about the quality of your changes. And as I mentioned before, this techniques works with execution of automated tests, whether it's unit test, API test, Selenium-based UI test, or manual testing as well. Overall, it doesn't matter which testing techniques you're using. We have the centralized system for analytics and visualizations, which collect all the information coming from those different testing practices. We collect information about your code metrics, about your static analysis violations, results of test executions, code coverage, and so on. And the system can visualize this information for you, and at the same time make some assessment about overall quality of your application. So it's kind of holistic view on the test quality of your projects. And I'm not going to talk much about that. Again, you can visit our website and read more about this. This is probably one of the last slides, which I just want to kind of summarize that we focused on application of AI machine learning in the testing through obviously automated test creations, optimization of test executions, self-healing as part of that, and basically noise reductions when we're talking about static analysis violations, and try to optimize the user's work and developers' time to focus on fixing and testing what matters the most to still produce high quality products. You can read more about our products and offerings on our website.